Ever wondered how pilots navigate their way through the vast, open skies? It's a question that has intrigued many, especially those with a keen interest in the complex world of aviation. To grasp this, we need to delve into some key terminology that forms the basis aviation navigation: TAS, IAS, and CAS. These acronyms represent the pillars of airspeed measurement and navigation, crucial for understanding how pilots navigate. TAS, standing for true airspeed, is the speed of an aircraft relative to the airflow it's moving through. On the other hand, IAS, which stands for indicated airspeed, is the speed read directly from the aircraft's instruments. Lastly, we have CAS, or corrected airspeed, which is essentially the indicated airspeed corrected for instrument and installation errors. Understanding these terms provides insight into the intricate mechanisms and calculations that enable safe and precise navigation. These aren't just terms, but the science behind how pilots conquer the skies, making the impossible seem possible. Let's dive into the world of aviation and unravel the mystery behind these terms. True airspeed, often denoted as TAS, signifies the velocity at which an aircraft is moving concerning the surrounding air particles. It's a crucial factor in determining an aircraft's performance and ensuring the safety of its passengers and crew. To further understand this concept, let's take a moment to imagine a scenario. Visualize a large plane slicing through immense clouds, propelled by its powerful engines. It's flying at an incredibly high speed or against a forceful wind. The atmospherics are constantly changing, the wind speed, the pressure, and the temperature all fluctuating. The aircraft is not just moving against these forces, but also through a sea of air particles, each interacting differently based on the aircraft's speed and direction. It's important to realize that these particles don't stay stationary. They rush against the plane, increasing the pressure on its external surface. Now, as the speed of the aircraft increases, so does the pressure of these air particles against the plane's surface. Conversely, if the aircraft slows down, the pressure at this point, you might wonder, how is this pressure measured? This is where TAS comes into play. The additional pressure felt by the aircraft, resulting from its speed or the force of the wind against it, is accurately measured by TAS. This helps pilots maintain appropriate speeds and ensure safer, more efficient flights. In conclusion, TAS represents the speed at which an aircraft is moving in relation to the air particles around it. The additional pressure felt by the aircraft due to its speed or wind is what TAS measures. Now, let's talk about indicated airspeed, abbreviated as IAS. This is a term that is vital in the realm of aviation. It refers to the speed that is read from the aircraft's onboard instruments. It's an important concept for pilots as it reflects the plane's performance under current environmental conditions. It's basically the aircraft's speed relative to the surrounding air. This value is displayed by the airspeed indicator, which is a critical instrument located on the aircraft's control panel. To elaborate further, the airspeed indicator displays the value of dynamic pressure. This dynamic pressure, also called Q, is a significant part of the force that the aircraft experiences while in motion. To determine this dynamic pressure, a simple calculation is, one would take the total pressure and subtract the static pressure from it. This operation usually involves the use of a graph. This graph plots the total pressure from the pitot tube on one axis and the static pressure on the other. This process helps in understanding the aircraft's performance in different conditions, making IAS an essential aspect of aviation. Although the focus is often on TAS, or true airspeed, and IAS, or indicated airspeed, these two do not always correspond due to variations in air density, temperature, and other elements. In the world of aviation, airspeed is a critical parameter that pilots need to understand and manage accurately. The reason is simple. It tells them how fast their aircraft is moving through the air. However, this airspeed can be influenced by various factors, such as changes in atmospheric pressure, fluctuating temperature levels, and differences in air density. Even seemingly minor details, like the friction between the fluid and tube or the elasticity of the capsules, can cause the TAS and IAS to differ. This difference is not a fault or failure in the aircraft's instruments. It's a natural result of the complex and ever-changing conditions in which aircraft operate. Given these variables, it becomes evident that there's a need for another type of airspeed measurement. One can account for these variances and provide a more accurate reflection of the aircraft's speed. This is where corrected airspeed, or CAS, comes in. CAS is essentially IAS, but with valuable corrections applied for air density, making it a more reliable airspeed indicator. In summary, true airspeed, TAS, is the actual speed of an aircraft relative to the air around it. Indicated airspeed, IAS, is the speed read from the aircraft's onboard instruments. Corrected airspeed, CAS, is the IAS adjusted for changes in air density. Remember that perfect match with the international standard atmosphere and mean sea level conditions is rare. An aircraft flying at altitude often encounters lower air density, especially with temperature increases. This is important to recall your next flight. There's a complex world of calculations and corrections happening in the background, all to ensure a safe, smooth journey. TAS, IAS, and are three critical components that enable this. So the next time you're on a flight, remember, there's a lot more to the journey than just the destination. There's a world of calculations and corrections going on behind the scenes, ensuring a safe and smooth flight. TAS, IAS, and CAS are just three of the key components that make this possible.